A Borg-Warner 35 transmission has 3 forward gear ratios and reverse. The selector lever works in a quadrant with 6 stations: park, reverse, neutral, drive, second, first. With D selected, the vehicle will move off in first gear, will change to second and then to third, in accordance with road speed and engine load. Downshifts from third to second or second to first are also fully automatic, unless the driver resorts to kickdown. Kickdown changes are useful when short bursts of acceleration are required and occur at higher speeds than automatic changes. Automatic upshifts occur immediately accelerator pressure eases, following a kickdown. Automatic gear changes may be overridden by use of the 2 and 1 selector positions. If 1 is selected from rest, first gear will be held until the selector is moved to 2, when second gear will engage. Moving to D will then give third gear, provided that road speed and throttle opening are suitable. Selector position 2 also permits automatic changes, but from first to second and from second to first only, depending on road speed and throttle opening. Third gear will not engage in this position. With the vehicle cruising in third, selecting 2 will cause an immediate downshift to second. Selecting 1 in similar conditions causes an immediate downshift to second and then, when road speed drops sufficiently, to first. Full engine braking is available in both second and first gears. This also applies when the vehicle is in reverse. The planetary gear set is a Ravigno type with primary and secondary sun gears, primary and secondary planet pinions, and 1 ring gear. The ring gear is attached to the output shaft. The planet carrier is mounted in the transmission case on a one-way clutch. Both sets of pinions are in the planet carrier. They mesh in pairs. The longer outer secondary pinions mesh with the ring gear at their outer edge. At their inner edge, they mesh with the secondary sun gear. The smaller primary pinions mesh with the smaller primary sun gear. The planet pinions transmit the drive from the sun gears to the ring gear. In all forward ratios, drive is transmitted through the primary sun gear. In reverse, it is transmitted through the secondary sun gear. Control of the planetary gear set comes from the operation of 2 multi-plate clutches, the one-way clutch and 2 brake bands. The outer plates of the front clutch are splined to the input shaft from the converter turbine. The inner plates are splined to the primary sun gear shaft. The inner plates of the rear clutch are splined to the front clutch drum. The outer plates connect to the secondary sun gear. The front band wraps around the outside of the rear clutch drum. The rear band is on the outside of the planet carrier to hold the planet carrier stationary when it is applied. When the rear band is in the release position, the one-way clutch lets the planet carrier rotate forward, but not in a reverse direction. These are the components and control elements engaged in each gear range: the front clutch, the rear clutch, the front band, the rear band, and the one-way clutch. The front clutch combines with other elements to provide the required ratios for all forward gears. When D is selected, the front clutch is engaged. The one-way clutch acts as the reaction member, holding the planet carrier stationary and stopping it rotating in the opposite direction to the input shaft. Power flow is from the input shaft through the applied front clutch to the primary sun gear, which turns clockwise. Since the primary sun gear is meshed with the primary pinions, the pinions rotate anti-clockwise. This turns the secondary pinions clockwise on their pins on the locked planet carrier. The secondary pinions turn the ring gear and the output shaft in a clockwise direction at a reduced ratio and with increased torque. The gear reduction in first gear is 2.39 to 1. The secondary sun gear rotates freely in the opposite direction to the primary sun gear. On overrun, when torque is applied from the road wheels, the one-way clutch unlocks and allows the planet carrier to rotate. The transmission free wheels and no engine braking is provided. In selector position D and also in position 2, the front clutch and the front band are applied to obtain second gear. When the transmission changes from first to second, the front clutch remains engaged and the front band is applied to lock the secondary sun gear to the case. The secondary sun gear now becomes the reaction member. Power flow is from the input shaft through the applied front clutch to the primary sun gear and to the primary pinions. The anti-clockwise rotation of the primary pinions turns the secondary pinions clockwise. Since they mesh with the secondary sun gear and the ring gear, they walk around the stationary sun gear and rotate the ring gear in a clockwise direction. In both drive and overrun conditions, torque reaction is taken by the applied front band, which holds in either direction. The gear reduction in second gear is 1.45 to 1. In selector position D, the front and rear clutches are applied to obtain third gear. When the transmission changes from second to third, the front clutch remains engaged. The front band is disengaged and the rear clutch is applied. Since both clutches are now applied, the input shaft is locked to the primary sun gear through the front clutch and to the secondary sun gear through the rear clutch. With both sun gears locked together and to the input shaft, there is no relative motion between the gears. The whole gear set rotates as one unit to give a direct drive with a ratio of 1 to 1. In selector position 1, the front clutch and the rear band are applied. Application of the rear band locks the planet carrier to the case. Power flow through the gear set in the drive condition is the same as in selector position D, first gear. Drive is transmitted through the front clutch to the primary sun gear and through the short and long pinions to the ring gear at the ratio of 2.39 to 1. However, on overrun, the locked planet carrier acts as a reaction member, so full engine braking is provided. In reverse, the rear clutch and the rear band are applied. The rear clutch locks the input shaft to the secondary sun gear. The rear band locks the planet carrier to the case to provide the reaction member. The input shaft turns the secondary sun gear clockwise. The secondary pinions turn anti-clockwise on their pins on the locked planet carrier. The ring gear and output shaft turn in the reverse direction with a ratio of 2.09 to 1. Full engine braking is provided on overrun. The hydraulic system has a crescent-type gear pump, a centrifugally operated hydraulic governor, and a control valve body assembly to regulate the pressure and direct fluid to the appropriate components. The pump is driven by tangs on the converter spout and operates whenever the engine is running. It supplies all the hydraulic requirements of the transmission during operation. The governor is driven by the transmission output shaft and provides a hydraulic pressure that varies with vehicle speed. This variable pressure is used by the valve body as one of the inputs to control upshifts and downshifts. The valve body has all the valves needed to control the transmission at all stages of operation. They are mostly spool-type valves, but disc and ball check valves are also used. Cylindrical spool valves have a number of distinguishing features. The lands are the raised portions of the valve, while the reduced diameter between each pair of lands is referred to as a valley. The face of each land is square and sharp to the land diameter. Some valves have a stem or extension on one end to locate a regulating or return spring or to limit valve travel. Sharp corners on lands keep out dirt particles and give the valve a self-cleaning action as it moves back and forth in the bore. There is only small clearance between lands and the bore for each valve, so they must be handled with care. Spool valves can be positioned manually, or by springs, or by pressure, and in many applications have lands of different diameters. In this case, the different diameters result in a larger face area on land 1 than on land 2. This is known as a differential area. When fluid under pressure enters port B, this differential area creates a differential force. This moves the valve to the left since the force acting on land 1 is greater than the force on land 2. Alternatively, the valve could be moved by admitting fluid at port C. In both cases, the valve movement allows previously blocked fluid at D to flow between lands 3 and 4. It exhausts at E or passes to some other part of the system. If fluid pressure is removed from C, the valve remains stationary. Even if fluid is admitted at port A, no movement can occur as the areas on lands 2 and 3 are equal and both generate an equal force. The valve can only be moved back to its original position by introducing spring pressure or fluid pressure on the left-hand side of land 1. The valves can be divided into two groups: pressure regulating valves and those that direct flow and pressure, or flow control valves. Spool-type valves are suitable for pressure regulation in automatic transmissions, as variable pressures are needed. In this regulating valve, the valve spring is compressed when pump or supply pressure is high enough. The larger land then uncovers an exhaust port to maintain a regulated output pressure. Similarly, with this regulating valve in a fluid circuit, the valve is forced downwards against its spring until it uncovers a port to another part of the circuit. Since the port is not fully uncovered, flow is restricted, which causes a pressure drop across it. Fluid pressure in this part of the circuit falls below that of the fluid being supplied. Once the port is fully uncovered, pressures on both sides of the valve become equal. Control valves are simple gate-type valves, which open or close off a circuit without altering pressure. The manual valve connected to the gear lever is a control valve, which directs fluid to components when a drive range is selected. Control valves can also react to changes in pressure. This shift valve is held at the end of its bore by spring tension. It blocks the fluid under pressure at port A. The larger differential area at port C is subject to governor pressure. As road speed rises, the rising pressure forces the valve to the left, and fluid flows across from port A to port B. This can be directed to operate the next clutch or servo, and change the transmission to a higher ratio. As road speed falls and governor pressure diminishes, the spring moves the valve back to cut off the fluid supply and the transmission downshifts. Orifices are often used in conjunction with spool valves to restrict fluid flow for timing purposes or to prevent valve fluctuations. The orifice is designed to prevent sudden or undue movement of a valve. In this basic primary regulator valve, the orifice is in the circuit leading to the large differential spool area. The build-up of line pressure from the pump acts via the orifice to move the valve against the spring force. This uncovers the exhaust port to release excess fluid and allows fluid at a controlled line pressure to pass to the rest of the hydraulic system. The pressure is determined by the tension of the spring. However, pressure fluctuations are reduced because the orifice prevents the valve from reacting quickly and thus stabilizes the regulated pressure. Servos in automatic transmissions convert hydraulic pressure acting on a piston into a mechanical force. In this transmission, a front and a rear brake band are used. A servo is required for each. The rear servo is a pressure apply spring release type. Its piston has a central stem which locates in one end of the rocker arm to transfer the apply force to the band. A lever-type spiral spring returns the servo and band to the off position when the fluid is dumped. The rear band holds the planet carrier stationary when it is engaged. It is applied in drive ranges with low ratios. The high apply force required is provided by a combination of the large diameter piston and the leverage provided by the rocker arm. Fluid at line pressure is converted to an apply force by the piston, and this acts on the longer end of the rocker arm. The apply force is multiplied to about 5 times its value, then applied to the free end of the band. The band contracts and wraps itself firmly around the planet carrier drum to lock the planet carrier to the casing. An adjusting screw threaded in the casing provides the anchorage point, so the band can be easily adjusted when necessary to compensate for wear. The front servo is a pressure apply pressure release type with unequal piston areas. It is engaged with the front clutch to provide second gear and acts on a line spring steel band to lock the secondary sun gear to the casing. The apply force from the piston is transferred through its central stem and multiplied by the rocker arm with its leverage ratio approximately 3:1. This applies the band firmly when second gear is engaged. The apply fluid acts on the smaller piston area surrounding the hollow portion, which accommodates the return spring. If road speed is reduced, the 1-2 shift valve will move to the first gear position. This apply fluid will be exhausted at the 1-2 shift valve, letting the spring return the band to the off position. If road speed increases, the transmission will eventually upshift to third gear. This requires the rear clutch to engage, together with the already engaged front clutch. The front band must be released, but the apply fluid is not exhausted to provide this change. The apply fluid is retained. Then, when the 2-3 shift valve moves to supply fluid to the rear clutch, the same fluid is supplied to the release side of the front servo. Equal line pressures act on each side of the front servo piston, so the larger area on the release side generates greater force. This moves the piston to the released position. If the accelerator is depressed for kickdown, or road speed drops off, retaining the apply fluid can provide a snap band application to re-engage second gear. Clutches in automatic transmissions control gear train members. This transmission has 3 clutches. A one-way or overrunning clutch is between the planet carrier and the center support. A multi-plate clutch is inside the drum attached to the input shaft, the front clutch. A multi-plate clutch is inside the drum attached to the secondary sun gear, the rear clutch. The one-way clutch is a sprag type. It locks the planet carrier to the center support whenever the carrier tends to turn in the opposite direction to the transmission input shaft. The inner race of the clutch is provided by an extension on the center support. The outer race is formed in the planet carrier. The equally spaced sprags are held together by a spring-loaded cage. It maintains them in the correct position and attitude. Correct fitting is essential, otherwise the planet carrier will freewheel when it should be locked up, and no drive will be transmitted in D-range first gear. With the sprags in place, the cage moves them so that they share the load equally when the planet carrier is locked. Turning the planet carrier in the opposite direction to the input shaft pivots the sprags towards the larger radius and wedges them between the 2 races. The front clutch is a multi-plate type, engaged in all forward ratios. The clutch operating piston moves in a short cylinder in the clutch drum. A diaphragm-type spring contacts a fulcrum ring on the piston at its inner circumference. Its outer edge rests against a step in the drum. A pressure plate is installed first in the clutch pack so that its fulcrum ring also contacts the diaphragm. When fluid at line pressure is admitted to the clutch cylinder, the piston apply force is multiplied by the leverage provided by the diaphragm. This exerts a greater apply force on the clutch pack than the piston alone could provide, and ensures the clutch is firmly engaged. The spring returns the piston to the off position when the fluid is dumped. Two sets of plates make up the clutch pack: the driving plates and driven plates. The outer driving plates are flat. External splines locate in mating splines in the clutch drum. The inner driven plates have friction material bonded to them. Their splines mate with splines on the outside of a central hub, which is itself splined to the primary sun gear. The friction material can be treated fiber or reinforced paper. It may have a grooved surface to assist in wiping oil from between the plates when the clutch engages. The plates are loaded into the clutch drum against the pressure plate and are placed alternately to make up the pack. The central hub is installed to engage the inner plates and the thrust washer placed in position. The large face of the input shaft acts as the final plate in the pack. The splines at its outer edge transmit the input torque to the clutch drum and the driving plates. The input shaft is retained in the drum by a large diameter snap ring. The number of plates installed determines the torque capacity of the clutch. Installing more plates increases torque capacity, but the clutch must always maintain its set clearance so the plates can separate from one another while in the released position. A centrifugal relief valve in the clutch piston releases fluid trapped in the cylinder when the clutch is released. This prevents partial application of the clutch due to centrifugal force acting on the fluid at high speed. The rear clutch is similar in construction to the front clutch, but with a larger diameter piston and a coil-type return spring. This spring is compressed against the face of the clutch piston when fitted. The outer plates in this clutch are the driven plates, and are splined to engage with the splines in the clutch drum as before. These plates may have a flat surface or a slightly dished or coned surface. The dished plates provide a cushioning effect, which assists with smooth engagement when the clutch is applied. The plates may be fitted as a pack, with the dishing in either direction, but all of the dishing must face the same way, or clearance may be compromised. The inner plates are splined to mate with splines on an extension on the front clutch drum. They transmit the drive from the input shaft to the outer plates when the clutch is engaged. The clutch plates are assembled in the pack alternately, with a steel plate placed first against the clutch piston. The pressure plate is assembled last, and the pack is retained in the drum by a snap ring.
فراموش نکنید که توی کانال سابسکرایب کنید، زنگوله رو به صدا در بیارید و کانال رو با دیگر دوستانتون به اشتراک بذارید. تا ویدیوی بعدی، روزگار خوش.